stop and jot and begin by writing down everything you think about when you hear the word function. Just brain dump it. Does anybody remember the definition? What? Okay, you're brain dumping on your paper. Yes.
Each input has to have one output.
You're like white hot, but not there. Every input has at least one, no more than one. Exactly one. Exactly one output. Okay, so it's a rule where each input has exactly one output. Oh my goodness.
It's crazy. So here you go.
Sorry, it's a little bit.
All right, what else do you remember about functions?
Oh my God.
Do you remember any tests for functions?
Linear.
Vertical line test. Anybody remember the VLT?
Oh yeah.
No.
Vertical line test.
I thought you said BLT. Sandwich.
Like, making me hungry. All right, what else? I heard some specific types of functions. What kind of functions do you remember? Hey, what kind of functions do you remember learning about? Exponential. What else?
Quadratic.
Yes. I feel like quadratic lasted forever. We had 2 quadratic units back to back. That's why. We had Unit 5, we went home for Christmas, and then we came back and we solved quadratics. We graphed them before Christmas and solved them after. Okay, what other kinds of functions? Linear. All right. The ideas are starting to shake out. Do you guys remember anything about the puts?
Inputs, outputs.
Inputs and outputs?
Dude, I don't have any room.
Okay, do you remember any fun words that start with D and R?
Oh,
Domain and range.
You're off now, Robert. You're taking me.
Okay, it's all coming back to us. All right, where have you heard the term function before?
Algebra.
Algebra. Okay, and then what did it mean in that context? I think we already wrote that down. So it kind of meant this, right?
Yeah.
Okay, I'm not going to make you write it twice. I'm feeling sweet today, or just tired. Am I sweet or just giving up? It's hard to say. Okay, in statistics, we are still going to use this definition where each input in our rule has to have exactly one output. But we are going to expand it to include considering a distribution as a function. Okay, so this kind of has some similarities to graphs that we made in Algebra 1. We've got an x-axis and a y-axis. So looking at this histogram, what might our inputs be? What variable would be for our input? Yeah, the quiz scores. So the input, remember, is on the x-axis. These are our quiz scores. Okay, what about the output? The frequency, this is on the y-axis. Do you guys remember that X, Y goes in alphabetical order, input, output goes in alphabetical order, and domain and range go in alphabetical order? Right? So that helps you always make sure that you know that X is the input and the domain, and the Y is the output and the range. It's just a gift from the math gods that they just all go in alphabetical order. All right. So looking at this histogram and distribution, we are going to make a T-chart for the quiz scores and frequency for first hour. All right, so T-chart. It's been a while, but I think I can swing one of those. I've got my quiz scores that are going to be my X's, like my X's, and my frequency, which are like my Y's. All right, so how many kids got a 0 on the quiz? 0, thank God. Okay. 1,
0,
2,
0,
3.
0,
Okay, this is a boring one. 4.
0,
Jeez. Okay. 5.
2,
Okay. 6.
3.
I'm running out of room. Anyone else running out of room?
Yeah.
I'm just going to have to keep going out of this box. Okay, I can't see the histogram anymore, so I'm just going to rely on you guys not to make up some weird stuff. All right, what about a 7?
4,
Okay, now we're talking. 8?
3,
Oh, okay. 9?
2,
10?
1.
Okay, there's always 1, right? Okay, so you guys remember when we used to test T-charts to see if they were functions, and we would check each input and made sure that it only had one output? So does 0 only go to one value? Okay, 1 only maps to 0. 2 only maps to 0. 3 goes only to 0. 4 only goes to 0. Does this fit our definition of a function? Yes. Yes. Because each input maps to exactly one output. Okay, I switched it up a little bit and I said maps to. That's a new vocab thing. Do you guys remember when we did the things like this? And those are called mappings. So a mapping is just another way to say like a relation rule. So if I say this input maps to that output, it just means this input gives us that output. Cool? You remember that? Okay. All right, any questions about? Okay, we're moving on. Cruising. All right, the domain of a function is the set of all possible what values? What? X values. Okay, so after getting the first one right, the second one is a little bit easier. The range is the Y values. Okay, do you guys remember function notation? No. Super fun. Okay, the notation f of x is read as f of x, where f is the name of the function. That way we can have different function rules that we're talking about at the same time. We can call one Fred and one Ginger, F and G, or H, like Hilda or whatever. X stands for an input value in the domain of the function. And f of x represents the output value in the range of the function that corresponds to the input value x. So X is the input. The X's are the domain. They correspond to F of X's, which are the outputs, which constitute the range. Easy peasy lemon squeezy. This geometry is kind of like algebra, so it's kind of my jam. Okay, the table at the right shows the results of a survey of teenagers who were asked about the number of hours they sleep each school night. Okay, so this is the number of hours slept on a school night. And then this is the frequency. So how many kids said that they slept 4 hours on school nights? Just one. Okay, what about 7 hours? 10. Okay. So what do you notice about the data in the table? You see any fun patterns? It goes up and down. So if you're kind of picturing what that would look like it kind of, maybe kind of like a quadratic, an upside down one or a right side up one?
Upside down.
Upside down. Okay, yeah. So we're going to imagine that the data is kind of like a mound. Okay, it has a peak and then it tapers off at the ends. So what kind of shape is that? Yeah, this is going to be roughly symmetric. Okay, so it goes up and down is what you said. Goes up and down. And we also said roughly symmetric. Okay, we have to create a graph of our data with the information from the table. Okay, so I might need a little bit of help for this because I can't really look at my graph and my table at the same amount of time. So what is the highest X value that we have? 10. So you're looking in the left-hand column. So what do you think we ought to skip count by for our X values? What?
I think one would be common.
Okay, let's skip count by ones, but label every second one. Okay, so 0, whoops, sorry. 0, 2, 4, 6, 8, 10. Okay, and what am I putting on the x-axis from the table?
Number of hours.
Number of hours. Specifically, hours slept. Okay, what is my biggest Y value, my biggest frequency?
10.
Also 10? Can I do the same thing on the Y-axis?
Yeah.
Okay, and then what is the label for my Y-axis? How many kids or frequency? In this case, they mean the same thing. Okay, so I've got frequency versus number of hours slept. Okay, this is where I'm going to need your help a lot because I have no idea what the table is. All right, so how many kids said 0 hours? 1?
Huh? 0.
2? Okay, what's the lowest? 4. How many kids said 4? 1. Okay, so we're going to put a dot at 4, 1. All right, what's the next lowest? How many said 5? Ooh, kids not getting enough sleep. Okay, what about 7? What's next? 6? Okay.
9.
9? Okay, hilarious. I did not make up this data. I would not have done that to myself. All right, next.
7.
7 has how many?
10.
Okay.
8. 8.
8, 8. Okay.
Do we draw a little
9.
thing, like a line
9.
Hold on.
next to that?
What? 9 was 5?
Yes. And then 10.
10, 1. Oh, that would have been me. Okay. So I guess my question is, we're going to come, okay, someone asked if we connect the dots. We're going to come back to that in like 2 seconds. Just give me a minute to circle back. Okay, could the relationship between the number of hours slept and the number of students who reported those hours, the frequency, be described as a function? Why or why not?
Yes, it can be described as a quadratic.
Okay,
It's like
we might be able to say it's approximately quadratic, but there are very specific rules for being quadratic. Do you guys remember finding the second differences and all that?
roughly.
Okay, where you had to like find the rate of change twice and it had to match. You guys remember doing that?
No.
Okay. All right. So, why is this a function? Each input has exactly one output. Is there a specific special test we could also use on this because we have a graph? We could also use the vertical line test. So we could say it passes the vertical line test. The vertical line test says that any time I take a vertical line and draw it through my relation, that it should only be hitting that relation in one spot at a time. If this was a graph right here, this little C shape I'm making with my fingers, and I drop a vertical line through it, you see it hit twice? Okay, my little finger C is not a function because I've got 2 outputs for 1 input. I've got stacked points, which is bad. Okay, passes vertical line test. And we also said the definition, each input, I don't know why I'm hearing whispering. Each input has exactly 1 output. All right. Could the graph we generated be described as a function? Yeah. We kind of already said this, but what does it pass? Passes the vertical line test. Okay. This time we're going to abbreviate it. Okay. Last one on this page. If you could describe this data as a function, which set of values would be considered the domain and which set of values would be considered the range? So the domain would be the what?
Number of hours.
Okay, the hours slept. What about the range? The frequency. Okay. Rocking and rolling. Suppose that f is a function that maps the number of hours slept on a school night to the frequency of that response. How would you interpret f of 5 equals 6? F of 5 equals 6. F of 5 equals 6. Okay, wait. Okay, so where is the input? Is the input the 5 or the 6?
5.
It's the 5. So we're going to color code it. 5 is the input. Is the input the X or the Y? The X. Okay, and the 6 is the output. Which is the Y. Okay, so which side of this table is X and which side is Y? The left, okay, you said that in a weird order, but you were right. So this side is the X's, and this side, I know, I said you were right, but you said it like where I had to think really hard about it and use my brain. So, does this help? Okay, I want you to try it. Try it and check the people around you. Make sure your partner people have it and that they're not losing their minds.
Which people is left on that?
Correct. 6. Six people slept 5 hours. Or if you wanted to like say it like a robot, you could say the number of people that slept 5 hours is 6. Okay, that would be like, you know what I mean? That's why in that order it's like
5 hours slept equals 6 people.
the number of people who slept 5 hours is 6, right? But no one really talks like that. But that's what the math says. All right, next. Okay, don't get distracted on me. Okay, what is the value of f of 7 and what does it mean in context? So what does f of 7 equal?
7 hours slept.
F of 7 equals what? 10. Okay, it's saying what is the output for the input 7?
Oh.
The output for the input 7 is 10. Does everybody see what it's asking for?
Yeah.
Okay, what does it mean in context? Do what you did up here.
Every 10 people slept.
Stop.
10 people slept for 7 hours.
Are you sure it's not 7 people slept for 10 hours?
Yeah. Yeah.
Okay, good, because you're right. 10 people slept 7 hours. Okay. What is the contextual domain of this function? So what is the domain in context? So I'm not just asking for like the specific elements of the domain. So I'm not asking you to say 4, 5, 6, 7, 8, 9, 10. That would be a list of the actual elements in this set. Like in the context of the situation. Hey, I'm up here trying to do my job. Come on, bug you at work. Okay, so contextual domain is like, what are those representing in this situation? 4 what? 5 what? 6 what? 7 what? Hours of sleep. Okay, what about the contextual range? Okay, so again, we're not asking for the specific values that are the elements of the range. We're asking for what those elements represent. And those are the people who slept however long, right? Yeah, then how many students?
So you just write students or numbers?
The number of students. Okay, is that the end of that page? No, it's not.
No, listen to that.
Okay, in this data sample, no students reported 5.5 hours or 7.3 hours 7.3 repeating hours But are these values possible inputs?
Oh, yeah. I don't know.
Okay, so do you guys remember when my friends over here, they were kind of like yelling stuff out and they were like, do we connect these dots? You guys remember that? And I was like, wait, we're gonna come back to that? Okay, let's get in a time machine. Okay, let's say that we're going back to algebra. And I'm telling you that we are going to graph the little function f of x equals 2x. Okay, and we want to make an input and output table. So here's my x's, here's my f of x's. You guys writing this down?
Yep.
Okay, so my usual suspects are -2, -1, 0, 1, and 2. Okay, what does my function rule say to do to those inputs? Multiply them by 2, times them by 2. So 2 times -2 is -4. 2 times -1 is, wait, yeah. I don't know why that was hard. 0, 2, 4. Okay. So let's say that we graph these. Oh my gosh, it's so much work. It's the easiest algebra problem ever. I can't believe it. Okay, so -2 is sending us to -4. -1 sends us to -2. 0, 0, 1, 2, 2, 4. Now, in this function rule, we picked those inputs because they were easy. But could I have put 1/2 in here? Could I have done 0.5? What's 0.5 times 2? 1. So there's another little itty bitty point in there. Isn't there another one if I do 1.25? Okay, so what did we do when we graphed this line? We didn't just plot the points, we connected them because it's continuous. Does everybody understand what I mean by continuous?
Forever and ever.
Forever and ever. But not only that, it's continuous, it goes on forever, but I also don't, listen! I also don't pick up my pencil when I draw it. There aren't any breaks. Okay? I could get infinitely many numbers in between each of these inputs, and they would each still, put your phone away, they would each still have an output that is on this line. Everybody with me? Okay, so back to the question from the peanut gallery. Yep. Okay. Even though no students reported sleeping 5.5 hours or 7.3 repeating hours, are these a part of our conceptual domain? Like, could we kind of connect these points and make a curve? Okay. So write that down.
Right. What?
Are they possible inputs in our conceptual domain?
Yeah. We have to explain them. We can say yes. So the question doesn't say.
Okay, that was a good loophole. Loophole spotted. Got it. All right, next one. Complete the table by comparing the frequency function to other functions you have studied. Okay, we're going to take, I want you to maybe do that for an assignment. Yeah.
Homework backward in Greek language is torture.
Okay, we're going to do some binning. Okay. Hey, when I stop talking to give you time to write or turn your page, that is not an invitation to have an additional conversation. That means do it and let's move on. Thank you. Okay, a doctor's office staff has studied the wait times for patients who arrive at the office with a request for emergency services. The following data was collected over a 1-week period. We have to make a frequency table using a bin size of 4 minutes. Okay, so my bin size has to be 4. So I'm going to go 0 is less than or equal to, you want to do X or T for time? Okay,
Yeah, we'll do
that's
X.
fine. It's not what I would have picked, but I can handle it. Okay, is less than,
Is just less than or not? Equal to?
well, it's got to be less than because in the next bin, we're going to get 4 is less than or equal to X. So if I get, hey, look, put your eyeballs up here. If you have the size, if you get the data point 4, which bin are you going to put it in? Look at me. Does it go here for less than 4 or here is greater than or equal to 4? Greater than, or, do you understand? Like we can't put it in 2 bins. So this needs to be just a less than symbol and this is going to be less than or equal to. Is that okay with everybody?
Yeah.
Okay.
So if it is,
If it's 4, it's going to go in this bin. You remember where in our settings on Desmos when we changed the histogram from aligned on center to aligned on left? That's what this means. It's going in the left side of the bin. We could have aligned it on the right, but that's an odd choice. Okay, the next bin is going to go from 8 to 12. Okay, the next bin is going from 12 to 16.
good job. Where are we going by fourth?
Yes, because what does it say? The bin size is.
Oh.
Okay, we have to have, yeah. Okay, the next one would be 16 is less than or equal to X is less than 20. Okay,
20, 24.
correct.
Hey.
All right, now we get to sort this data. Where does the 0 go?
The 0 goes on the first.
First bin, because it can be equal to 0, right? All right, what about the 5? Second bin. The 10? Third. The 12? Ooh, this is a good one. Does it go in the 3rd or the 4th bin?
Third.
The 4th. Because look, it has to be less than 12 to go in the 3rd bin.
Oh.
You see why we couldn't put or equal to on both bins? Because then it would be in both bins and that would mess up our thing. So it's going to go in the 4th bin. What about the 5? Second bin. 17. 5th. 13. 4th. 18.
Fifth,
5th. 9.
third, yeah.
And 8 both go in the 3rd bin. Two of them at a time. Okay, 12. 4th bin. Not the 3rd bin.
You starting to make sense now?
21.
Wait, which one? 7?
21.
Oh, last.
Last bin. 7. Second bin. 3 goes in the first bin. I almost said 4 goes in the first bin, but where does 4 go? Second bin, and there's 2 4s, so I'm going to put them both in there. Boom, boom. 8, third bin. 11, third bin. 6, second bin. And the 3, first. Okay. You just have to trust me that this is a lot harder to do on the board because it's so close to your face, it's a little disorienting. Like imagine trying to do your notes and your face is like right there. It's a lot. So I'm sorry if I messed up. Did you guys all get 3 tallies for the first bin?
Yeah.
Okay, 6 for the second. 5 for the third. 3, 2, 1. Okay. Okay, so just looking at our frequencies, What do you kind of notice about the shape? It's going to be skewed. And it's skewed right because the tail is on the big end, right? Okay, so good. All right, now we're going to use our frequency table to make a histogram. So I'm going to rely on you because I can't look at them at the same time. All right, so what goes on our x-axis? What are we plotting?
Wait time.
Wait times in minutes. Good use of units. Wait times in minutes. What is our largest wait? Oh, we have to count by fours, right? Okay.
I just kind of jumped. I did like 2,
0,
4, 6, 8.
4, 8, 12, 16, 20, 24, 28. Did I do that right?
Yes.
Okay. It's bothering me that I don't have a 32. Okay, it's fine. Okay. What goes on this side? What is our label for the y-axis? Frequency. Okay, so what is the highest frequency that we have? 6. So can we count by ones?
Yes.
Okay, help me out. Our first bin from 0 to 4, did that have 3 in it?
Yeah.
Okay, next bin. 6. Okay. 8 to 12 bin. 5?
So yeah, 5.
The 8 to 12 bin?
Yeah, 5.
Okay. Oh. Okay, the 12 to 16 bin.
3.
Okay, next bin.
2.
Last bin.
1.
Oh, that's pretty. Okay, what do I need at the top?
Title.
Title.
Love title. Just name it. Harry Potter.
Okay, what else do we have to do on this page? Okay, what is f of 9 according to the histogram function whose bin size is 4? Okay, so where's 9? 9 is between 8 and 12. So what is the output for 9? 5. So we can say f of 9 is 5 what? 5. Ooh, minutes is the x. So the 9 is the minutes. Is it people?
Yeah.
Okay, so the number of people who reported, that's the height of that bin. We don't know that those 5 people all reported 9 minutes. So it's saying the height of the bin for 9 is 5. All right, let's see what we got on the next page. We're in a good spot. Okay, so this one is 8 minutes. That one you can do on your own. Oh,
Can we start homework right
okay.
now?
I want you to do the 8 minutes and the 2 minutes on your own, and then we're gonna come in and talk about them. Okay? Can you guys do that?
Not like tonight.
I want you to do them tonight. That was fast. We did that in under 10 minutes.
So like,
I will let you start on it now.
Or are you saying, are we done for the day?
No, you're starting on the
I mean, like, done.
history. Yeah, we're done with me. You're done with me.
That's so smart.
That's the important question, right? Do we still have to listen to you? No, you do not.